Cool. All right, here we go. Algebraic expressions. Algebraic expressions. Let's learn some of the basics again. Today we'll also investigate factoring. Factoring, you love to factor, right? You're like really good at it. You're like, I'm awesome at that. Okay, sweet. All right, so it says perform the indicated operation. You need to be able to look at an expression and understand the operation to be performed. What is the operation in this one? Addition, we add. You're adding these two polynomials. When you add polynomials, you simply combine like terms. We have 8x squared. Then what? Minus 8x. Minus 14. Nice job. You're smart. So letter C, if I go there, well, it looks like I have these numbers out front. So I should distribute my 3. I know that, so I get negative 6x squared. I get a plus 3x. I get minus 9. Now, should you distribute positive 4 or negative 4? Yeah, just distribute the negative 4. If you have a subtraction sign in front of parentheses, you must distribute that. So I get a negative 16x squared plus 20x minus 4. Now what? Combine like terms, negative 22x squared plus 23x minus 13. Good. How about letter B? What do we do there? Distribute what to what? Yeah, in mathematics we say that we do that. Okay. Hey, you might be wondering, why do we do that? You ever wonder why you do the things that you're told to do? Yeah. Okay, can I just quick show you why that's what you do? And algebra was the last of the mathematics to really be developed. It was the last. Calculus, trigonometry, geometry existed long before algebra. So if you check out the geometric representation of what you're looking at on the board, it's very simple. You have this going on, okay? You have the 4x, you have the minus 2, and you have the 2x, and then you have the 7. And if you're going to find the area of that, isn't the area of that 8x squared? Right? And then isn't the area of that negative 4x? The area of that is 28x, and then the area of that is 14. So that's what's actually happening. For every single problem that you see, there's actually a geometric representation of it. So that's why you do what you do. So we distribute the 4x, as we see, you get 8x squared. You get the 28x. Then we distribute the negative 2. We have negative 4x and a minus 14. Am I done? No, obviously you can see that you can combine like terms in that scenario. 8x squared plus 24x minus 14. Now, it is true that you could factor that expression. You could take out a 2, but it does not say to leave it in factored form, does it? So just because something can be factored does not mean it's more simplified than another result. How about letter E? If I square that, 9x squared plus 16, yes? Why? How? Very good. Square something means to take it and multiply it by itself. So 3x minus 4 times 3x minus 4. I will get 9x squared plus 16 on the test from people. Stop doing that. Okay? Stop altogether. So I multiply, I get 9x squared, and then, yep, minus 12x plus 16. So I get 9x squared minus 24x plus 16. Y'all good with that? Do letter F on your own real quick. Questions? I'm trying to decide what's for supper tonight. Pork chops. But they're not on sale. I am feeling the full effects of inflation right now. I need things on sale. I don't have enough money to make it through the year. Ugh. Taco Tuesday. We can always do Taco Tuesday, right? It's Tuesday. Do some tacos. We'll see. Yep.
that one, we just add the exponents to each other then, since we're not directly multiplying exponents.
Try that again.
Kind of like multiplying negative 2
Yep.
5 against 10.
Yes.
So then this, since that's being multiplied, since this is not being, this 3 is not being directly multiplied.
Right.
We can just add them.
Yep. Yep. Okay. Everybody agree that letter D looks a little bit more difficult? Okay. I look Taylor in the eyes and she says that looks really frustrating right there. So I hear you. So let's make the problem easier. Should we make it easier? So I think instead of having fractions and radicals, let's just have one. Let's have either fractions or radicals. So let's try to create exponents with fractions. So I've got x to the 3 halves times 2x to what power? Square root is the same as what power? 1/2. Yes. Minus 3 times x to what power? The square root of x to the 5th is x to what power? 5 halves. Remember, square root, we don't write the 2 there, but it's assumed. If it was a cubed root, then it would be over 3, so on and so forth. Okay? So that's what we have. And now we will go ahead and we will distribute. Now, if the problem wasn't set up like that, if it was set up as x to the 3rd times 2x plus 3x to the 5th, you would say no big deal, right? You just add the exponents. So let's keep that same idea in mind. Let's add the exponents. So if I add these exponents, I'll end up with 2x to what power? Squared, because it's 4 halves, which is squared. Minus 3x to what power? 4th, because it's 8 halves or 4. Good. See that little trick? That's going to come up in your assignment. You'll probably have a question on a couple of those problems. When you get to your questions, don't freak out. Let's just go through them together. Let's go over our factoring methods. Common factor. Greatest common factor is always the first factoring method we look towards. What do you take out? 2x squared. I take that out. 2x squared times what is 4x to the 3rd? 2x. 2x squared times what is negative 6x squared? So I got a 3 right there, and that's factored. Okay. You do letter B on your own. Go. Yes? Does the 3y just disappear? Very good. So this is not correct, yet people will write this on the test. I want to be clear. You can always check your answers every time you're factoring. If you multiply, you get 9y to the 4th. If you multiply here, you get minus 12y squared. You can tell right away that's not the same as that. So at least if you get it wrong on the test, you should know it's wrong because you could go back and multiply through and see that it's not right. So every time you do this type of factoring, you should be able to take out that 3y and then say, I have 3y, and 3y times what is 9y to the 4th? 3y cubed. 3y times what is 3y? That'll be the 1 that you spoke of. And then 3y times what is 12y squared? That'll be a 4y. So please keep that in mind. Trinomial with leading coefficients of 1. We see a 1 here and a 1 there. These type of trinomials factor to 2 binomials. This should be reviewed as well. We have x times x. In this situation, we look at the 2 numbers that multiply to negative 33 that add to negative 8. What are the 2 numbers that multiply to negative 33 and add to negative 8? Negative 11 and positive 3. Could I also write x plus 3 times x minus 11? Is that the same? Yep, because multiplication is commutative. 4 times 5 is the same as 5 times 4, right? So no big deal. Could I write x minus 3 times x plus 11? No, that is not the same. That will not work out that way. Try letter D on your own. I've got minus 16 and positive 3. Do you know how to tell if a number is divisible by 3? Is the number 105 divisible by 3? Why? It is. Yeah, if you add up the numbers, if you add 1, 0, and 5, you get 6, right? Is 6 divisible by 3? So this is also divisible by 3. Yep, it works with 3, and it also works with 9. So if it's divisible by 9, then it's so on and so forth. Now here's another thing. 48, you guys know it's divisible by 6 and 8, right? Well, if it's divisible by 6, then true or false, it must be divisible by 3. Yeah, in fact, 3. So you divide by 2, so if I multiply by 2, you get 16 there. So yep. So if it adds up to something divisible by 3, then you know that it works for 3. Flip it over. Trinomials are coefficients of a not equal to 1. So you see we have an 8 and we have a 2. There's 2 methods that will teach you to do this. First hour said that they had not learned the second method. We'll see if that's the case. But I have 8x squared plus 10x plus 3. I use the guess and check method. So I know I have 3 times 1 on the end, and this will be either 8x and x, or it will be 4x and 2x. What would you like to try? All right, let's try the 4x and the 2x. So it's going to be a 1 and 3, or a 3 and a 1. Any thoughts? Yeah, 3 goes there, and the 1 goes here. And the way that you can confirm that is to just multiply it out. You know that the 4x and the 2x multiplies the 8x squared. I'm good there. You know the 3 and the 1 multiplies 3. But if we check the inside and the outside, you can see I have 6x and 4x that adds to the 10x. So we've checked and we are good. Has anybody seen that problem worked out using the AC method? Okay. Alternating current. All right, we're doing electricity. Let's go. 8x squared plus 10x plus 3. Please just follow along. Some of you guys have seen it. This is the way I teach it. If this is ax squared plus bx plus c, we call it the AC method because you take the a value and multiply it by the c value. And you get x squared plus 10x plus 24. Beautiful, right? Now, does that factor to what? X plus 4 and x plus 6. We all good there? Now, let's admit, if we multiply this out right now, there's no way we'd be getting an 8x squared, right? So we know it's not finished. So the number I moved was 8. So I'm going to put it right back there. Okay? Now, to finish this off after you put the 8 back, you simply look. What are both 8 and 4 divisible by? And actually 4 as well, right? So let's divide by 4. We get 2x plus 1. Divide both sides. What are both 8 and 6 divisible by? Divide them, you get 4x and 3. And so there's your factorization. AC method. Does that look familiar? Yes. Okay, so I look at 8 and 4. They're both divisible by 4. So I divide it by 4, I get that. These are both divisible by 2, so I get that. Let's try it again. Let's do the other problem. Okay, we do the AC method. I take the 2 times the negative 4. I get x squared plus 7x minus 8. Is everybody with me so far? So then at that point, I separate it into x plus 8 and x minus 1. Notice how I always leave a little space by the x. What number did you get rid of? 2. So what number should we bring back? 2. Just place the 2 in front of those. And to finish it off, you just look at your terms. What are both 2 and 8 divisible by? 2. And you get x plus 4. What are 2 and 1 divisible by? 1. So it's just 2x minus 1. And that's factored. Now here's the bigger question. Why does it work? And it's kind of one of those things, a lot of times teachers don't like teaching the AC method because a lot of students don't understand why it works. In fact, a lot of math teachers don't understand why it works either. They just do it. So if you're interested, I'll show you a proof. It takes about 30 minutes. But okay, difference of 2 squares. This is your favorite one, right? 9x squared, so I go 3x and 3x. Yeah, you got a y squared and a y squared. Plus or minus. You love difference of two squares, don't you? Yeah. It's like for Christmas, I could just buy you a worksheet of difference of squares factoring, and you'd be like, yeah, let's go. Thank you. I'll do this whole day. Try letter H on your own. Right or wrong? Why?
You can't put an x squared plus 1. You can't get the right.
You can only do with minus?
Because when it comes to we put the minus
Very good. I love what I'm hearing. So you guys see this through the entire way. The subtraction sign, yes, factors. The plus sign does not factor. Somebody even said imaginary. It actually works out. It does factor. It factors x minus I and x plus I. So it doesn't factor in a real sense, but it does factor in an imaginary sense, which is kind of cool. I'd like to show you one more reason why it does not factor. If you were to look at the graph of the following, y equals x squared minus 1, what shape does that make? So the P, rhymes with parabola. Parabola, very good. So we got this parabola, and it's shifted down 1 unit, right? How many times did that parabola cross the x-axis? Twice. And as you see, it factors to x plus 1 and x minus 1. So it crosses the x-axis at -1 and +1. Beautiful. And if you have y equals x squared plus 1, and we graph that, that again is a parabola, but instead of being shifted down 1 unit, it is shifted up 1 unit. How many times does that cross the x-axis? None. So it does not factor for real solutions. See that? Mathematics will come alive when you can see that the graphs and the algebra are all connected together. They're all connected. It's quite beautiful, actually. Okay, let's try. We got 2 more pieces here. Okay, sum and difference of cubes. All right. See if you remember this formula. We got a formula for you. I'm going to put it on the board, but my board space is over there. Where's my little eraser? Like, who even makes this stuff up, right? It's like, who's got time on their hands for all this algebra stuff? Okay, so here's what we have. I'm going to put it right over here. And here's how it goes. If I have a cubed minus b cubed, here's how it factors. Factors to a binomial and a trinomial. Okay, binomial and a trinomial. So 2 parts and 3 parts. And it's very simple. Okay, what do you multiply 3 times? Well, we'll start with the plus. What do you multiply 3 times to get a cubed? A. So a goes there. What do you multiply 3 times to get b cubed? And b goes there. If there's plus here, then there's plus here. Simple so far, right? I mean, you used to look at the formula like, well, that is really complicated. Not that bad. Now, this number here is simply that squared. What do you get if you square that? A squared. What do you get if you square that? That goes on the end. Pretty simple so far, right? You just find the first 2, square the front, square the back. This is always positive. Okay. And then you get the middle, you just multiply those 2 together, AB. And then that sign is always opposite. If this is minus here, then this is minus there. And this is plus over there. That always stays plus. Okay, so let's put it into practice. You need to memorize that. I will not give you that on your first test. You can do it. I know you can. Because you are super smart. The best of the best. And here we go. I have 2 cubes. We factor them. What do you multiply 3 times to get x cubed? X. What do you multiply 3 times to get 8? Dos, which is Spanish for 2. Plus or minus? Minus. Easy so far, right? Square the front. X squared. Square the back. 4. Multiply the 2 together. 2x. That's always plus. This is opposite that. You can remember that, right? Yeah. Let's try the next one. The trinomial that results, very rarely does that factor. Okay? 8x cubed. 2x. Y to the 6th. Y squared. Plus or minus? Square the front. Square the back. Multiply the 2 together. Back is always plus. Middle is opposite the front. Not too bad, huh? Math is always easier the second time you see things. You know what I mean? The first time you see it, it's kind of gets clogged up your brain, but now you got relevance, things like that. And we do the last example. Grouping. Grouping. We need to factor by grouping. When we don't see a greatest common factor, it doesn't fit all the other examples that we've seen. Sometimes we could try a grouping method, especially if there's 4 parts to it. Never put a parenthesis down in front of a negative sign. Why? What is the value of that 5? Is it positive or negative? It's negative right now. What if I do like that? Is it positive or negative? Now it flips to positive. So when you put parentheses down in front of a negative, you change the value of numbers. So if I go x cubed plus 5x squared, and then I go plus a negative x minus 5, now I can put parentheses down in front of those. What common factor can you take out of x cubed and 5x squared? Take out the x squared. What remains? X plus 5. What can you take out of negative x and negative 5? Negative 1, and I'm left with x plus 5. Great, so I've removed a common factor from each. What factor do they now both share in common? They share an x plus 5. Take out the x plus 5, and we are left with x squared minus 1. Oh, and then that is the difference of 2 squares. So I've got x plus 5, I've got x minus 1, and x plus 1. Sweet. We end with letter L. Try it on your own. Go. Should factor out an x plus 2, and you're left with 3x cubed plus 7x. You should recognize that that x can be factored out to be x times x plus 2 times 3x squared plus 7. That's that. Okay. You have now time to work on your worksheet 1.3. You only have about 5 minutes left before school's out. I know that's kind of a bummer. We did take some time off of classes in order to do things like flex. So don't quite have as much maybe work time as you maybe normally would. I'm sorry about that. If you're looking for a challenge, you could try the tougher factoring problems down here if you'd like. If you're a little bored tonight, you want to try something, give them a shot.